So in fluid mechanics analysis, okay, so in any fluid mechanics or fluid dynamics analysis, it is important to know what kind or what types of analysis available in order to solve for any fluid mechanics ataupun fluid dynamics analysis. Okay, so first I would like to explain about all this approach ataupun all those analysis that available in order to solve for fluid mechanics ataupun fluid dynamics problem. Okay, so first, in order to solve for fluid, in order to solve for fluid mechanics, okay, mechanics mean that it can be static, it can be moving ataupun dynamic. Okay, so both. We have three methods or three approach. The first one is called finite difference method, which is FDM, and then the second one is experiment, and then the last one is finite control volume. Okay, so FCV. Okay, so this is the three methods ataupun approach that can be used to solve for any fluid mechanics problem. Okay, so what is finite difference method? Of course, if you refer to the name, okay, finite difference method mean that we need to difference, okay, ataupun we need to differentiate in order to get the result, or in order to get the variable at the nodes. Okay, so for the finite difference method, of course we need to use numerical scheme. Okay, numerical scheme, what is numerical scheme? Nanti you akan belajar lah numerical scheme. Ada finite difference, okay, ada banyak method untuk numerical scheme. So this scheme, this approach is used in order to solve for the finite difference method. So of course, if we are using the finite difference method, it requires the use of very how to say, a lot of equation, okay, a lot of equation that need to be solved, and then this equation is solved based on the finite difference method. Okay, so what is finite difference method? So let's say you have in order to solve for, you want to solve for this problem, you want to analyze what happened, okay, what happened inside this pipe. Okay, so and then you need to discretize. Okay, then okay, so this is discretized based on grid. Okay, so setiap ni akan ada point. Okay, so we need to solve all the point ataupun all the nodes based on the finite difference method. Of course, this cannot be calculated on paper, so you need to use HPC ataupun high performance computer, okay, in order to solve for this kind of method. Okay, of course, when you want to use high performance computer, the main drawback ataupun the main problem is related to the resources. For example, expensive, okay, the price of the HPC itself, and also in terms of time consuming. Okay, so in order to solve ataupun in order to get an accurate result based on this number, based on the number of nodes it requires a very long simulation. So that is for finite difference method. But dalam kita punya MEC 441 kita tak akan adalah finite difference method. Nanti kalau you nak apa nama ni, di tahun akhir you boleh ambil apa nama ni, course CFD. Okay, CFD Computational Fluid Dynamics. Okay, so kalau you ambil CFD course untuk elective, you akan belajar lah benda-benda macam ni, how to use that numerical scheme in order to solve for any fluid flow problem. Okay, so that is method number 1. And then method number 2 is experiment. Okay, so experiment means that we use any experimental apparatus in order to get the data. Okay, for example, we can use wind tunnel. Okay, so what is wind tunnel? Wind tunnel is used in order to obtain the forces. For example, in order to obtain the forces and moment, okay, around body. Okay, tak kira lah apa, kalau you nak tak, let's say we want to determine drag of car. Okay, how much the drag coefficient for the new design car. So we can use wind tunnel in order to get that coefficient. Okay, of course that coefficient is based on forces, which is drag ataupun lift coefficient. Okay, and then if normally the car is length of the car ataupun the size of car is really large. Okay, so that's why in order to do the experiment, normally we can scale down that object ataupun kereta tu sendiri, kita scale down. Kalau 4 meter, kalau kita scale down ke 2 meter, dia akan jadi scaling factor dia half, 1/2. But by using the scaling approach ataupun by using the scaling method, we need to apply the similitude analysis. Okay. Okay. So for the similitude analysis that we'll be learning in chapter 4, we use similarity. Okay, mean that what happened to the forces ataupun what happened to the forces at a large body ataupun large car to the scale is similar. Okay, maknanya kalau Reynolds, we can use for example Reynolds number similarity. Contoh Reynolds. Okay, so maknanya apa kat sini? Reynolds number similarity mean that we can use Reynolds number for model, the actual model equal to Reynolds model for the scale model. Okay, so based on this, we can identify what is the required velocity, okay, for the wind tunnel, so that we can get that kind of similarity. Okay, so this will be learning in chapter 4. Okay, for the experimental based on similitude and dimensional study. And then for this chapter number 3, we use finite control volume. Okay, so why this finite control volume? Of course, we need to identify the control volume. Okay, so the control volume can be deformed. Okay, it can be deformed. Control volume can be a fixed control volume. Okay, that we'll be learning in this chapter is a fixed control volume. And then it can be a motion ataupun a moving control volume. Okay, but interesting in this finite control volume is we will apply all the conservation that governs the motion ataupun governs the fluid mechanics ataupun fluid flow analysis. Okay, so what is the conservation? So there are 3 conservation that we'll be learning. Conservation of mass, okay, conservation of energy, and then conservation of momentum. Okay, so conservation of mass, nickname dia adalah continuity equation. Okay, so conservation of momentum, we use momentum based on first Newton's law, and then a second Newton law, and then third Newton's law. We use that type of law in order to derive the momentum, the linear momentum equation. Ataupun kalau dalam fluid mechanics kita famous dengan nama Navier-Stokes equation. Okay, and then last kali, which is energy, conservation of energy. Okay, energy in tolak energy out equal to delta change of energy in the system. Okay, so energy, dalam energy for this chapter we will be learning how to apply the energy equation in order to find the pressure difference, for example, in order to find the pressure head, in order to find the velocity head, in order to find the elevation ataupun elevation head. Okay, so this will be learning, all those things will be learning in this chapter, which is chapter number 3. Okay, so but bear in mind, even though this finite control volume is use mass energy atau conservation of mass energy momentum. Okay, so the finite difference method also use the same conservation. Maknanya dia, in order to do the analysis based on finite difference method, we need to use, or we need to satisfy all those three conservation. Okay, conservation of mass, energy, and also momentum. Okay, boleh? So there is mukaddimah 15 minit untuk for this chapter. Okay, then okay, so semua okay ke? Clear?
Okay, sir.
Okay, saya proceed. Okay, so objective of this study, apply the conservation of mass. So what is mass? Apa semua tu kita akan explain using this chapter. Okay, so what is control volume? First, we need to define the control volume itself. Okay, so how to define the control volume? Okay, so in this control volume, there will be a boundary. Okay, for example, let's say we want to analyze a steady flow device. Okay, steady flow device such as nozzle. Okay, nozzle. Okay, so let's say this is nozzle. Okay, connected from the hose to the nozzle, and then we want to analyze the velocity, for example, and then we want to analyze what is the required force. What is the required force? Let's say kalau this nozzle, the very big nozzle, and then we need to find what is the required force here. Okay, F, R, X, and then F, R, Y, sama kat sini. F, R, X, and then F, R, Y. Okay, so kita tahu berapa anchoring force ataupun required force in order to hold the nozzle static. Okay, maknanya dia tak bergerak. You boleh imagine kalau hose nozzle untuk bomber, bomber dia kena guna 2 orang untuk hold the nozzle steady. Maknanya dia tak melantun. So that requires the study of fluid dynamics ataupun fluid mechanics in order to analyze what is the velocity, what is the pressure, okay, that produced from the nozzle. Okay, and then in order to study that, we need to use, or we need to identify the control volume itself. Okay, so let's say we want to analyze what happened to the nozzle, so we can create the control volume. Okay, so the green dash line here represent the control volume. Okay, so this is the control volume. Dalam control volume ni, this is the boundary yang kita panggil boundaries. Okay, so maknanya kita ada, let's say this is inlet, you can identify this is inlet, and then this is outlet. Okay, so what happened to the mass at the inlet, and then what happened to the mass at the outlet. So this will be learning in for the part 1, okay, for the part 1 in this chapter. Okay, so this is called the control volume. Semua ni, and then control volume is surrounded by the boundaries. Okay, for this type of control volume, okay, for this type of control volume, it is it can be coincide, okay, dia coincide with the real boundaries. Okay, yang ni boundaries untuk control volume which is imaginary, and then yang hitam ni, yang black color, it is known as real boundaries. Okay, so yang ni lebih kurang macam mana kita nak identify control volume. Okay, so control volume can be used to find flow velocity. Okay, so based on mass, based on conservation of energy, based on conservation of momentum, we can find velocity, we can find the forces. Okay, this for force analysis and also motion analysis. In fact, we can find the pressure. Okay, we can find the pressure, gauge pressure based on energy equation. Okay, so there is some overview how to set up ataupun how to choose your control volume. Kalau yang jenis macam ni nozzle, it is fixed control volume. Boleh proceed?
Boleh sir.
Okay, very good. Okay, so this is type of control volume. There are fixed in space. Yang saya buat tadi nozzle, contoh apa lagi? Kalau you nak study apa lagi? Kalau fixed nozzle, kalau motion ataupun deforming piston, okay, piston dalam silinder engine cylinder, yang tu deforming ataupun deform punya control volume. Okay, so two type of control volume, which is volume is fixed in space ataupun kita namakan dia Eulerian type. Okay, so macam tadi Eulerian type lah sebab dia fixed in space. So fluid can freely pass through the volumes of one tree. Ni maksud dia apa? Fluid can freely pass maknanya boleh masuk inlet, and then ada inlet, ada outlet. Okay, and then volume is attached to the fluid, which is Lagrangian type. Volume is freely carried out along with the fluid and no fluid passes through its boundary. Yang ni dia attached to the fluid, maknanya dia bergerak ikut fluid. So this is essentially the same as the free body concept employed in solid mechanics. However, for our focus based on fixed control volume ataupun nama dia Eulerian type of control volume. Okay, yang ni Eulerian dengan Lagrangian type ni untuk MEC 441 you just tahu fixed dengan attached to the fluid. Okay, tapi dalam MEC 442 you akan belajar detail what is Eulerian type and then what is Lagrangian type of control volume. Okay, but our focus based on Eulerian type for this course MEC 441. Okay, so these three pictures ataupun these three figures shows the chosen of control volume at this is at for the system. This is the system, and then this is the control volume. Okay, so if at kalau tengok B, system and control volume at time T coincide. Sekarang ni dia dah coincide with the system. Okay, and then kalau tengok C, system and control volume at time T, dia dah bergerak ke depan. Dia punya system dah bergerak, but the control volume is fixed. Yang ni kita panggil Eulerian type of control volume. Okay, so this is basic understanding about the control volume. Okay, so this is a few example of control volume. Yang ni apa? Diffuser dengan nozzle daripada besar ke kecil, dia punya surface area daripada large to small surface area. Kalau diffuser daripada small surface area to a large surface area. So yang ni kita panggil diffuser. So this is what we want to analyze. So we choose this control volume. And then this is moving control volume. Ada moving control volume. Moving ni maknanya dia bergerak. Control volume dia bergerak with the system. Okay, so for example, this airplane is the system, but we want to choose or we want to analyze only around the engine knuckle. Okay, so we can choose this engine knuckle as the control volume. So we need to consider the velocity of the plane, okay, the relative velocity of the plane, and also what is of course the velocity of air sucked into the engine knuckle. Okay, so this is moving control, example of moving control volume. Okay, so this is also another example of moving control volume, which is sprinkler head ni. Yang ni pernah tengok kat mana? Pernah nampak tak benda ni?
Nah,
Kat mana?
macam garden kan tu.
Ha?
Luar rumah.
Dekat padang kan, padang bola sepak tu. Nampak tak? Dia nak apa? Nak basahkan apa pun, nak siram nak basah rumput tu, dia guna this one kan, sprinkler punya spray water head. So this is also moving control volume. Okay, so this is deforming control volume yang saya mention tadi. Kalau piston, yang ni kalau apa nama ni, shrink, you boleh imagine shrink yang makan ubat untuk adik-adik you tu, yang tu that was considered as moving control, deforming and control volume. So let's say this is the control volume and it's deformed based on the motion of the piston ataupun this motion. Okay, so sama juga dengan apa nama ni, engine. Okay, engine motor, engine kereta, dia punya cylinder, dia ada the motion of piston up and down. Okay, so yang tu pun adalah deforming control volume. Okay, so this is also deforming control volume example. So you have the nozzle and then you choose this control volume. Maknanya kat sini if this is type of control volume, we can analyze what is the, for example, what is the required force. Okay, what is the required force Frx and then Fry in order to hold this apa nama ni, stopper. Okay, so barulah kita tahu berapa dia punya force yang kita kena apply in order to hold this stopper. Okay, so this is inlet, and then this is outlet. So kita boleh dapatlah what is force here based on momentum equation, and then what is the force here, and then what is the pressure. Pressure is, it can be considered as atmospheric pressure, so pressure is 0 for example. So sama kat sini, so this is deforming, also considered as deforming control volume. Okay, boleh? This is example ataupun types of control volume. Normally dalam problem kita dah tahu this is the control volume. So maknanya yang itulah kita akan analyze. But the most important is how to analyze that control volume. Okay, so in order to analyze that control volume, we must apply all these three conservation, which is conservation of mass, conservation of momentum, and conservation of energy. Okay, conservation of mass, mass in, and then what happened to the mass at the inlet, what happened to the mass at the outlet. Okay, so there is the simple analogy ataupun simple understanding about the conservation of mass, and then conservation of momentum. What happened to the force? Okay, what happened to the force at the inlet? What happened to the force at the outlet? Okay, so there is the momentum, and then conservation of energy. What happened to the energy? If let's say there are conversion of mechanical energy to thermal energy. So what happened to that kind ataupun to that type of energy? Okay, so now first we focus on conservation of mass. Maknanya mass kilogram. Okay, so that is mass. Conservation of mass is mass like energy is a conserved property and it cannot be created or destroyed during a process. Okay, so yang ni sama dengan first law atau first law of thermodynamics. Okay, so closed system, the mass of the system remain constant during a process, and then control volume mass can cross the boundary. Okay, yang saya buat tadi, mass can cross the boundary, and so we must keep track of the amount of mass entering and leaving the control volume. What happened to the inlet and then what happened at the outlet. And then mass is conserved. This is the illustration of mass is conserved. If 2 kg of hydrogen plus 16 kg of oxygen, and then the product, the combustion product ataupun after the chemical reaction, it will produce H2O, which is water vapor, 18 kg of water vapor. So yang ni kita boleh neglect, which is the mass change due to energy change. That will not be covered in this course ataupun in this chapter. Kita just focus on the mass, the conservation of mass. Oh, dia jadi macam ni. Patutnya saya tulis balik. So to conserve ataupun to satisfy the conservation of mass, okay, so we must satisfy both volume and also surface. Okay, so volume and also surface of control volume. So maknanya conservation of mass, okay, so conservation of mass must satisfy the control volume and also control surface. Sebab apa? Sebab let's say you choose the control volume, okay, you choose the control volume. Okay, there are volume that need to be considered, and also there are surface, this boundary that need to be considered. And then what happened to the surface? We can identify the velocity, contohnya at that particular surface. Okay, so kalau in this conservation of mass, kita akan selalu guna from today onwards, mana sampai bila-bila, you akan selalu dengar mass flow rate and also volume flow rate. You akan sentiasa dengar perkataan ni, mass flow rate and also volume flow rate. Okay, so what is mass flow rate? Dia punya notation adalah mass sebab ada rate kita kena letak dot, m dot, maknanya kalau rate dia per apa? Mass kilogram per time, which is second. Okay, the standard dia adalah per second. So kilogram per second untuk SI unit. So m dot, how to find m dot? M dot is equal to rho, which is density of fluid, multiply with the area. A is area, rho is density, and then V is velocity. Okay, so there is mass flow rate. Maknanya, let's say kita ada nozzle tadi. Nozzle kalau kita tengok dia kurang macam tu. Okay, so we can determine the mass flow rate at the inlet. This is inlet. This is outlet. Sebab apa? Sebab kita ada, let's say yang masuk tu air, kita ada rho, and then we can determine the area. Sebab apa? This is area. Area is pi d square over 4. And then kalau kita tahu velocity, so straight away we can find the mass flow rate. Okay, so that is how to find the mass flow rate. And then volume flow rate, V dot. So volume flow rate equal to apa? A kali dengan V. Ya ni. M bahagi dengan rho, M dot bahagi dengan rho. You betulkan rho ni sebenarnya sama dengan volume. Okay, sama dengan volume, which is volume flow rate. Unit dia apa? Volume unit rate apa? Meter cube per second. Okay, so M dot sebenarnya adalah M dot also equal to rho V dot, sebab AV adalah V dot, volume flow rate. Okay, so you akan sentiasa jumpa benda mass flow rate, volume flow rate untuk analisis, untuk apa? Untuk this type of analysis, ada fluid mechanics ke thermodynamics, you akan sentiasa guna ataupun sentiasa apply the mass flow rate and also volume flow rate. Boleh? So starting from today onwards, you kena sentiasa benda ni sentiasa you kena ingatlah mass flow rate and volume flow rate. Satu base kepada mass, satu lagi base kepada volume. Boleh?
Boleh.
Okay, so this is mass equal to rho AV tadi. Mass equal to rho AV, and then mass flow rate equal to rho AV, and also volume flow rate equal to AV. Okay, so both ada velocity. So velocity kalau dalam pipe, dalam nozzle, we need to consider the average velocity. Sebab apa? Sebab velocity, kalau kita tengok base kepada velocity profile, dia macam ni, velocity profile. So we need to consider the average velocity. Tapi dalam problem biasanya yang dibagi tu memang dah considered as average velocity. So we don't have to use this kind of equation in order to obtain the average velocity. Okay, so biasanya untuk mass flow rate, untuk volume flow rate, the average velocity, the velocity is also equal to the average velocity. Okay, so now we applying the conservation of mass. What happened ataupun how to describe the conservation of mass principle. Okay, so in words, conservation of mass equal to the net mass transfer to or from a control volume during a time interval delta T is equal to the net change ataupun increase or decrease in the total mass within the control volume during delta T. Okay, so yang ni bahasa dia lah. Yang sebenarnya M inlet tolak mass out sama dengan, of course lah, sama dengan change of mass in that system itself. Okay, ataupun kalau kita nak define in terms of mass flow rate, kita letakkan flow rate M dot inlet tolak M dot outlet sama dengan dm system over dt. So this is basically conservation of mass. Yang masuk tolak dengan yang keluar sama dengan perubahan ataupun change of the mass into the system. Contohnya yang masuk 50 kg air dalam bathtub ni, yang keluar 30 kg. So yang tinggal apa? 20 kg. So 20 kg is basically delta mass in that particular system. Okay, so this is the basic conservation ataupun basic principle for the conservation of mass. So now what is general conservation of mass based on control volume analysis? As I mentioned before, control volume analysis based on both control volume, based on volume ataupun control volume and also based on the control surface. So that's why the yang kita sentiasa guna, the general conservation of mass equal to change of rho dV per time, okay, rate of change for the rho dV plus with the rho V dA. Kalau you tengok kat sini, rho dV ni sebenarnya apa? V ni volume, volume. V besar, which is volume. Rho dV ni apa? Rho dV, kalau you tengok mass sama dengan apa? Mass sama dengan rho over
AV.
Sorry. Rho equal to mass over volume.
Volume.
Okay, so mass equal to rho V. So basically, the first rate of change ni, it is referred to the mass of the system per unit time ataupun m dot. Kat sini ni memang dah m dot for that control volume. Okay, and then kita tengok second term, rho V dA. Rho V dA ni apa? Sama dengan apa? V is velocity vector and then at the normal to the surface. Okay, so that is V vector and then normal to the surface. Rho V and dA ni apa? Yang kita belajar tadi?
Mass flow rate.
Mass flow rate. Sama lah, maknanya m dot untuk control volume tambah m dot untuk control surface. So that is the conservation of mass. The basic ataupun general conservation of mass. Sebab ni sama kan, rho, dia ada dA which is area, and then dia ada velocity which is mass flow rate. Boleh? So based kepada general conservation of mass kat sini, so kita boleh come out with a very simple analysis ataupun very simple equation in order to solve for our control volume. Okay, apa maksud saya? So kita tengok dekat special case yang ni, case by case. Okay, so during a steady flow process, what is steady? What is steady? Maksud steady saya explain sebelum ni. Apa maksud steady? Tak ingat dah? Tak ingat?
Constant.
Time is constant. So maknanya no variation of variable with respect to time. Okay, so maknanya yang berkaitan dengan time equal to kita cancel out. So maknanya yang tadi kita daripada general conservation of mass. Okay, so general conservation of mass tadi kita ada apa? D over delta T first control volume which is rho dV tambah for the control surface rho V N kali dengan dA. So maknanya yang equal to 0, kita tinggal. Daripada sini yang mana kosong? Yang mana kita boleh not to be considered? Yang mana? Yang ni kan, sebab dia per dt. Ni, kalau tengok first term ni, dia per dt. So yang ni tak adalah untuk kita punya steady flow process. So based on general conservation of mass, for steady flow process, yang ni is the first term is not considered because we are not considering the variation of time, the change of variable with the time. So yang ada apa? Only the second term. So integrate, meaning that for this based on this second term, we can conclude that for the steady flow process, okay, so steady flow process for steady flow device, rho Vn dA equal to m dot, okay, so m dot A tu variation of area, kalau nozzle dekat inlet to the outlet, so inlet tolak m dot outlet equal to 0. So maknanya for steady flow process ataupun steady flow device, mass flow rate basically equal to, setuju? Sebenarnya kalau untuk steady flow device yang masuk, mass flow rate yang masuk akan sentiasa sama dengan mass flow rate yang leaving the control volume. Setuju?
Setuju.
Okay, so based kepada general conservation of mass. So that's why for steady flow process, summation of inlet, mass flow rate for the inlet and then summation of mass flow rate for the outlet equal sama dengan inlet sama dengan outlet. Okay, boleh? So maknanya kat sini yang masuk kita tengok inlet masuk 2 tambah 3, yang keluar pun sama dengan 5 kg per second, which is the outlet m dot 3. Yang kita belajar ini, semua benda yang kita belajar ini, this is the most ataupun dia punya core dia kat sini. Yang you kena faham about the steady, and kalau sekarang ni kita cakap tentang steady, dan selepas ni kalau what happen to the steady and also incompressible. Okay, so yang ni faham untuk steady kenapa dia kosong? Untuk control volume sebab dia apa?
Constant time.
Constant time. Okay, yang ni. Okay, so kita tengok kalau dia steady and also incompressible. Okay, dia dah lah steady and also incompressible. So what is incompressible? Yang kita belajar dalam chapter 1 hari tu. Incompressible apa yang constant?
Volume.
Apa yang constant? Incompressible flow? Volume ke apa?
Volume.
Incompressible. Mana yang constant? Incompressible dengan compressible flow.
Mass.
Mass lagi? Tak ingat lah ni. Chapter 1. Apa yang constant? Compressible, incompressible flow. Incompress. Air dengan gas. Mana yang mudah lagi compress? Yang mana tak boleh compress? Sebab apa dia tak boleh compress?
Air
Dia
tidak boleh compress.
Sebab apa? Dia punya rho
Tinggi.
rho constant kan? Tak ingat Compressible, to identify compressible and incompressible flow, the easiest way is based on the density. Okay, so incompressible rho is constant. So that's why tadi for the special case incompressible and also steady flow device, kita tahu m dot in equal to m dot out. Okay, m dot in apa? Rho A in V in sama dengan rho A out V out. So now for incompressible flow, rho is constant. AV ni apa? A kali V apa?
Volume
Area.
A kali V?
volume flow rate.
Volume flow rate. So maknanya untuk steady and incompressible flow for liquid ataupun untuk liquid lah, kebanyakan liquid lah sebab incompressible. So V dot inlet also equal to V dot outlet. Sebab apa? A kali V sama dengan V dot. Boleh?
Boleh.
Okay, so yang ni dia punya core untuk conservation of mass yang you kena faham apa berlaku mass flow rate dengan mass flow rate dekat outlet, inlet dengan outlet. Boleh? Semua dah ada?
Ada.
Okay, so dapat idea how to solve that problem? Syafiq dapat? Syahidah? Amir? Nurin? Siapa lagi? Fahani? Dapat idea? How to solve for that problem? Okay, boleh? Boleh, tak boleh? Boleh, tak boleh?
Tak ada idea sir.
Idea So dia tanya, you have this water, a garden hose attached with a nozzle is used to fill a 10-gallon bucket. 10-gallon bucket tu apa? Tu apa? Quantity dia apa? Untuk apa?
Volume dia 10 gallon.
Volume dia je.
Volume. Okay, so there is the volume. Volume apa? V. Dan gallon. Gallon ni SI ni tak?
Tidak.
No.
How to convert 10 gallon jadi meter cube ataupun jadi meter cube lah. How to convert 10 gallon to meter cube. Try. Siapa boleh convert? 1 gallon berapa liter ataupun 1 gallon berapa meter cube. So gallon you kena guna UK punya conversion . Berapa? Siapa tahu? Ada tengah buat? Sepuluh gallon berapa? Tekanlah calculator tu. Tak ada calculator ke? Kan ada calculator saintifik.
0.038
Meter cube.
meter cube.
0.038 meter cube. Orang lain? Yang ni you tukar guna UK ke US?
US.
US. Kalau UK berapa? Tengok kat calculator ni ada kan? Gallon UK. Unit conversion. Nombor 15 kalau calculator saya ni 15. So 1 gallon UK sama dengan 4.54609 liter. Okay, so maknanya 10 gallon sama dengan berapa? Berapa liter?
45.46.
45.4609 liter. So tukar ke meter cube macam mana? Satu meter cube berapa liter? 1 meter cube 1000. Betul?
Betul.
Betul.
So sama dengan, kalau guna UK ni mungkin you all guna US, sama dengan berapa tu? 1, 2, 3. 0.0 1, 2, 3 4, 5 4 ataupun 455 0.0455 meter cube. So that is volume that was given. And then the inner diameter of the hose is 2 cm and it reduced to 0.8 cm at the nozzle exit. Ni maksud dia apa? So dia ada nozzle, side view for the nozzle. Okay. So diameter dia yang ni D1 sama dengan 2 cm and then reduce to 0.8 cm. Okay, so maknanya this is the given diameter for the nozzle. Okay, and then if it takes 50 seconds to fill the bucket with water. Okay, so dibagi apa ni? Dibagi time. Time equal to 50 seconds. Determine A, find. A, the volume and mass flow rate. Volume flow rate apa? V dot, and mass flow rate M dot. B, average velocity of water. Velocity lah. V. Okay. So macam mana nak solve? Ada idea? Dah dapat tu? Macam mana nak solve? Dia nak apa? Dia nak V dot. V dot ni sama dengan apa? V dot sama dengan A.
LV.
AV. Okay, so V dot equal to A multiply with the velocity. But now the velocity is not given at anywhere of the question. But we know that V dot basically unit dia apa?
M cube over time.
Over time.
Yes.
Second.
Second.
So kita ada tak M cube?
Ada.
Berapa?
0.0455.
Dia bagi tak masa?
Bagi
Bagi
50. So this is V dot. 0.0455 bahagi 50 meter cube per second. Berapa dapat?
-9.1 times 10 power -4.
Berapa?
9.1 times 10 -4.
So this is the volume flow rate for this nozzle. Okay, so maknanya kalau dalam masa 50 saat dia boleh isi 0.0455 meter cube, meaning that the volume flow rate for this system equal to 9.1 kali 10 - 4 meter cube per second. And then dia nak cari apa? B. Sorry. Ada lagi. Oh, mass flow rate M dot. M dot sama dengan apa?
Rho AV.
Oh, yeah.
AV kita tahu ke tak?
Tahu.
Tahu.
So rho AV sama juga dengan rho V
Tidak.
dot. So kali je lah. Rho ni water Water kita assume rho equal to 1000. Kali dengan 9.1 kali 10 negatif. So dapat apa?
0.91.
Apa unit dia? Kilogram per second.
Per second.
Okay, setakat ni faham? Yang ni just nak bagi you overview macam mana what is volume flow rate, what is mass flow rate. Maknanya kalau volume ni dalam masa berapa saat, berapa volume kita boleh dapat daripada nozzle tu. Okay, so that is the volume flow rate. Sama juga dengan mass flow rate kali dengan rho sahaja. So nak cari velocity macam mana? Velocity kat mana ni nak ni? Velocity at the nozzle exit. Macam mana cari velocity at the nozzle exit? Kita tahu we can do macam mana?
V in equals to V out rasa.
V dot kena sebut V dot. So kita V in equal to V yang you masukkan ni velocity.
Oh sorry, saya salah.
Bukan velocity. Yang constant dia sama apa tadi daripada conservation of mass tadi?
Density.
Density maknanya kita boleh tulis assumption sebab dia water ke. Assumption nombor satu steady and incompressible flow. Okay, so maknanya steady and incompressible. Apa yang kita belajar tadi? Steady and incompressible dekat conservation of mass tadi. Apa je yang kita dapat? Kita ada general equation for conservation of mass, d over dt, rho volume tambah control volume, control surface, rho v d dA sama dengan kosong. Yang ni kosong kan sebab steady. And then kita ada rho v dA. Rho v dA ni apa dia?
Mass flow rate.
Mass flow rate at the inlet tolak mass flow rate at the outlet equal to
0.
So kita tahu m dot in sama dengan m dot out. So maknanya yang kita dapat m dot ni ataupun v dot ni sentiasa sama. Tapi velocity dia tak sama. Sebab apa? Sebab luas dia tak sama. Betul?
Betul.
Okay. So kita boleh kira lah maknanya m dot out, kalau dia nak m dot out kan, m dot out sama dengan rho constant
VA.
Rho AV, rho
V.
A out kali dengan V out. So V out sama dengan sorry, tak ada dot V out sama dengan
A out.
m dot out bagi dengan rho A
Rho A out.
Okay. So A out macam mana cari? Nozzle maknanya nozzle dia punya cross sectional area dia adalah circle lah kan. So maknanya A out sama dengan
Pi R square.
pi r square. So dapatlah cari V out. Berapa dapat? M per second. Dah? Berapa dapat? We out?
1.81 darab 10 negatif 3 tu.
Berapa?
1.81 darab 10 negatif 3 meter per second.
Meter per second. Boleh dapat tak? 0.00 m dot 0.91 bahagi 1000 kali pi kali kosong 18 18
18.1.
18.1 bukan 1.81 apa bukan nozzle ni kalau 1.81 dia punya velocity tu kecil sangat. Silap kawan ni. Kawan silap? Tak apa. Kawan silap? Mesti ambil meter, ambil dimension dalam sentimeter kan. So dimension ni kena convert kepada meter dulu. 0.04 ataupun 0.08 meter. Betul?
Betul.
18.1 meter per second. Ya, ada soalan? Untuk example ni ada lagi? Ada soalan?
Tak ada.
Okay, so kalau tak ada soalan, basically untuk part 1 for conservation of mass, walaupun banyak benda yang kita belajar ini, yang perlu you tahu adalah the core of conservation of mass, which is the general equation. Okay, so general equation for conservation of mass stating that the change of rate of rho volume for the control volume plus for the control surface rho v dA equal to 0. Yang ni je yang kita belajar ini, yang kita perlu faham. Okay, so mass and volume flow rate. Mass flow rate macam mana? M dot equal to
Rho AB.
rho AV. V dot
AB.
AV.
AV. Okay, mass balance for steady flow process. Yang tadilah mass balance for steady flow process. Mass in tolak mass out equal to dm system over dt. Okay. Inilah mass balance. So maknanya kalau steady, yang ni tak ada, dapatlah m dot in sama dengan m dot out ataupun mass in sama dengan mass out. Okay, yang ni special case untuk incompressible flow tadi. Incompressible flow maknanya apa tadi?
Density
Is constant. So dapatlah V dot 1 ataupun V dot inlet sama dengan V dot outlet. Okay, so check. So settle untuk part 1 untuk chapter 3. Ada soalan?